Good morning, everyone in Science and Values. This will be the last lecture video for this week's class. This is about uncertainty and when scientists have to communicate uncertainty. It came up in the Douglas reading already, which is why I assigned this reading from the Elliot text because it's directly related to the um, the Heather Douglas reading about how to communicate uncertainty and what we can hold scientists responsible for when scientists have to weigh um, societal values versus their role as a scientist in order to only present factual information and the weighing of those two values against one another and how they should craft their message so that it might be able to balance both, or maybe they choose to balance one more than the other. And so that's what's going on in today's reading. So I had assigned pages 80, um, I'd assigned pages 82 to 93 for today, stopping at the section about choosing standard of evidence, which is for next week's reading. And so I just wanted to talk a little bit about that today because I do think that it's really important, this topic, especially in light of the pandemic that is currently still very much present in the United States and all over the world. And it's really interesting because we're getting into different territory here. How much should we have uncertainty when it comes to vaccine trials? And that's going to come up next week when we're thinking about whether we should raise or lower standards of evidence regarding vaccine trials in order to sort of fast track the vaccine. And so that there is uncertainty involved, but that shows that we might be valuing public health a little bit more than we would in terms of the normal procedures for safe safe trials. But in particular, as it relates to this week's readings, we're thinking about all the public health officials that we're seeing in front of us every single day. And as they try to figure out how to craft the right message, how to say the right things as they are in front of the public every single day. Obviously, in particular, you think of somebody like Dr. Anthony Fauci, who's out there, who was out there, during the month of April, during the press conferences that the White House was doing, and trying to figure out how to craft the right message, that there is uncertainty surrounding certain kind of things, but also the need to communicate. And so trying to balance the need to communicate important information to the public, but also trying to remind them that things are uncertain. And so, how do you balance those two considerations? It's a really tricky thing to do. And so this chapter begins with a really well-known episode. The scientist, Dr. James Hansen, who went in front of Congress in 1988. In fact, I'll post a link to a video that you can find. I'll post a link to a video that shows Hansen in front of Congress in 1988. Excuse me. And Hansen really, given the state of climate science at the time, Hansen made the calculation as he went in front of Congress that he was going to go beyond the available evidence and the available data and make a bold proclamation about the dangers of climate change and the all of the terrible things that could happen to the planet and to the population if action wasn't taken on climate change right now. Right? And so Hansen made the calculation to go a little bit above and beyond what the image of himself as this scientist who simply collects data. He has this responsibility to be honest and accurate in his reporting of data. But Hansen also took it upon himself to say that he had a role as a public advocate, that his role as a scientist wasn't simply one of neutral fact-finding, gathering, and reporting of data, that Hansen conceived of his role as a scientist as also a public advocate, somebody who had an obligation to advocate for a certain cause, to alert the public about the dangers of climate change. Now, again, in 1988, at the time, the science surrounding this wasn't as clear, but yet in the link to the video that I post, you'll find that Hansen has been vindicated largely. His modeling in 1988 and the things he was doing have turned out to be eerily accurate. So even though the data wasn't there at the time, Hansen went beyond the data to make predictions and get this message out to the public because he wanted people to start acting now, to start doing things to prevent climate change. Now, as Elliot mentions in the text, um, there was a large backlash from within the scientific community. Climate science itself, it still is a fairly new field, and at the time, it was also a fairly new field in science, in the scientific community. And so his colleagues were worried about the backlash that might result. So how could Hansen's calculation was to weigh the social values and the moral values of fighting climate change above the sort of purity of the fact-finding scientists. But Hansen's colleagues in the scientific community worried that this would lead to a distrust in the scientific community. That if they see a scientist out there advocating on behalf of climate change, that it's going to lead individuals to view scientists as advocates of causes rather than simply finders and discoverers of knowledge. And so now it's not an either or thing here, but this has to be something that this goes back to the Douglas reading. The question is, should Hansen have been thinking about the backlash and the distrust of the public to the scientific community, to the climate change community, when he decided to go in front of Congress and make this bold proclamation? And I don't know what the answer to this question is, but going back to Douglas's reading, Douglas is arguing that scientists have to be held morally responsible for the claims that they make, that claims are a kind of action that we can hold them responsible for, and that we need to have evidence that scientists have thought through the consequences of their decisions to release certain information to the public and to make claims to the public. And so what we have here is, in the case that Douglas gave, we have the evidence that maybe the safest thing to do would be to kind of balance your role as a scientist with your role as a public advocate, and to sort of build uncertainty into the claim. And so maybe we could imagine Doug Hansen getting in front of Congress. Instead of doing what he did, we imagine Hansen getting in front of Congress and saying, listen, climate change is a threat. It will pose a threat, but the science at this time is uncertain. But of course, there the worry is if you don't go far enough. Hansen probably did make that calculation. And Hansen thought, if I hedge too much, then the public won't think that climate change is a serious emergency. And he had this public platform in front of Congress, in front of millions of people in the American public. And Hansen decided, if I come out and hedge too much, and if I say climate change the science isn't sure yet, then it might not encourage the kind of bold action that he wanted people to take. And so Hansen made the decision to weigh the social value and the moral value of doing something about climate change above the epistemic value of only being certain before you say something. And so, again, I think this is a really interesting case, because it really does, it asks, first of all, I think it asks a couple of questions. It challenges the image of the scientist that we have, the image of the scientist as simply an advocate, the image of the scientist as simply a fact finder, and somebody who collects facts and reports the facts. And that's the image of the scientist that we have. And that image of the scientist tends to go more towards that value-free ideal that I've mentioned in several lectures. Whereas when we're presented with somebody like Hansen, who goes beyond the data, goes in front of Congress and advocates for a cause, we have a different image of the scientist. Now we have an image of the scientist as not just a neutral observer and reporter of facts, but as an advocate for causes, which starts to go into the realm of politics. And that might be worrisome for you as what you think a scientist ought to be, the image or the ideal of the scientist that you might think of as being true, but yet Hansen kind of challenges that. Of course, we have other examples today of these sort of advocates. We have people like Neil deGrasse Tyson and Bill Nye who are out there in the public eye all the time who might also be kind of challenging that image. So maybe that image is not one you have of the, but it's interesting to think about what image of the scientist do you have, and how does seeing someone like an advocate change that image of the scientist? Um, Now, I want to look at another interesting example that's brought up in today's reading. Um, and this is a reflection about two ecologists who present another perspective on uh, when you are communicating with the public or with other scientists, how you decide to present information and how you incorporate certain values. And so the episode, this takes place, this is on page 86, and this is two other cases. A scientist um, by the name of Patrick Kangas, and then another scientist by the name of uh, uh, Theo Colborn. So what's happening here is that this ecologist Patrick Kangas, he gets in front of this national meeting for ecologists. This is their International Society of Ecologists in 1986, and Kangas as an ecologist seems to need to believe and uphold certain things. And so when Kangas decides to get in front of this international meeting and say that extinction rates caused by deforestation might be lower than researchers previously thought, which I'm reading here just from the bottom of page 86. When this, he's an ecologist, he's in front of an international meeting for ecologists, and yet he's saying that that deforestation, which is tend to thought of as as a process that is actually very harmful to certain ecosystems and destroys natural habitats and things like that. You expect an ecologist not to be in some sense. The impression was that somehow he was saying that maybe deforestation isn't as bad as we think it is, and so therefore maybe if a imagine a logging or the timber industry sees a video, or they read about Kangas saying this, it simply gives them ammunition to for those who would oppose deforestation, they would come out and say, but look, we have an ecologist on our side saying that deforestation doesn't cause as much damage as we think it does. In fact, the economic value of deforestation is actually not as damaging to the natural habitat as we might think. And so there are not as many species being eliminated, and that therefore maybe we should increase deforestation and logging and timbering and things like that. And so the response to Kangas, an ecologist, was somehow that he had been a traitor to his own scientific community. And it's just really interesting. Now, and in fact, another scientist by the name of Reed Noss, which is mentioned on the top of page 87. Noss says that they worried he was trying to make sure ecologist results sorry, I misread. At the top of 87, it says, an influential ecologist, Reed Noss, criticized Kangas for drawing questionable conclusions that could harm society, insofar as developers could appeal to Kangas's results to promote deforestation. So that's the very thing I just discussed. So you've got somebody from within his own scientific community saying, look, you shouldn't be, you should be, remaining faithful to your own community. You've betrayed us in some ways. But of course, others come along and they criticize Noss for having this response. They said, look, a scientist's job isn't to come down one way or the other, even if the results don't comport with what you would like them to be. You still have a responsibility as a scientist to have a responsibility as a scientist to just simply report what the data says, not to be an advocate for a cause. And so, it's again, this is an interesting argument. On the one hand, we've got Kangas who's saying, look, even if in my role as an ecologist, I find out something that I don't like, even if I don't like the results, I still have an obligation, a role or responsibility, as Douglas would say, as a scientist, to report the data. However, also as an ecologist, as someone who is concerned about the environment, I also have a role as an advocate, to say that certain kinds of practices are harmful to society, harmful to the environment, and things like that. And so again, you've got this balancing of these two. Clearly, Kangas made the decision that he needed to stay more faithful to the data, whereas he was criticized for not being more of an advocate for ecology and not reporting the data, or at least but of course he would be accused of hiding the data and not being truthful. And so, you can just see how this is complicated. And this shows how scientists have to take values into consideration when they are deciding how to communicate with the public and how to communicate with other scientists. It's not straightforward. We have to ask the scientists to foresee the possible consequences of the things that they say. We saw it with Hansen, and now we see it with Kangas. Maybe Kangas should have thought, if I come out and say that extinction rates are not as bad as they were previously thought to be, then I am giving fuel to the timber industry, to the logging industry. However, if I decide to not report this data and it's discovered, then it also could lead to a distrust in science. And so the question is, how to balance these two, right? And so Elliot, I want you, I encourage you to read on page 87 and 88, pages 87 to 90. Elliot talks about the reasoning about these cases and what's going on with these cases. And one thing I want to take away from this, I'm going to allow you to read that on your own, but I do want to ask you, on page 91, Elliot gives a really helpful chart, and it really gives us three approaches that when there is uncertainty in data, it gives a scientist three different approaches in thinking about how to communicate. And in that chart, you can see them there for yourself, but there's one that's an advocacy role, which is going beyond what the data says a little bit. And maybe saying a little bit more than is there, but what you're trying to do is you're trying to encourage people to take the issue seriously and to go out and start acting so that the problem doesn't get worse. On the other hand, you could just take what we might call a clean hands approach and simply saying, look, I'm a scientist. The only obligation I have is to report the data. I'm not an advocate for any kind of cause, and therefore all I'm going to do is report the data. That's it. Then the other approach is a balance between the two, where you report the data. You also want to try to advocate, but you want to build uncertainty in. And that one seems like it might be the best approach. But of course, in that chart there, he gives some examples of drawbacks of each. And you might think that the balance of the advocacy approach and the clean hands approach, the modified clean hands approach, you might think that that's the best. But if you're hedging so much and you're saying, well, this is happening, but there's no certainty, the public might not take you seriously, right? And so there are all kinds of drawbacks to each one, and it's not going to be a one size fits all. It's going to depend on the case. It's going to be context dependent and context specific. But all of this is just to show that scientists, according to Douglas, we can hold them responsible for the consequences that result from some of the claims that they make. We have to see evidence that the scientist has deliberately and thoughtfully engaged in deliberation about the consequences of what they are going to say to the public. Now, there are going to be downstream effects that maybe the further removed you get, maybe the scientist isn't as responsible. There are going to be degrees of responsibility. But the argument, if we agree with Douglas, we do agree that scientists can be held morally responsible for some of the, not only the intended, but also some of the unintended consequences of the things that they say to the public. That is the bigger picture here. And that is obvious evidence that science must incorporate values. Um, because if they don't, then the values have the influence anyways, and they're not being transparent about it. And so, anyways, that big picture takeaway. I want you to think about those three different approaches. And indeed, big picture, I want you to think about the three different approaches, and I also want you to think about the image of the scientist. What is a scientist? Who is a scientist? What role do they have? Are they simply the neutral data? Are they simply the neutral, value-free observers of nature, collecting and gathering data and reporting it? Or is there something more? Do they have an obligation as an advocate to help the public take certain causes seriously and to act on those causes? And in particular, if you think about the pandemic right now, the scientist has to be out there encouraging the public to take this seriously. It might be a different case because the evidence is there of how serious the pandemic is, but we do have the image of the scientist here is more complicated than we might think. And that's all I have.